Hello and welcome to session 7 of 8 of our City and Guilds CAD exam preparation. Today we're going to look at beneficial techniques in 2D and 3D CAD, and we're just going to specialize on a couple of different techniques. There are many more, but these are some of the main ones that you will need to have knowledge of. Good luck. In this session, we're going to identify the benefits of using layers in drawings. We're going to describe some more benefits of using 3D CAD. We'll look at the benefits of keeping backup files for your CAD work. We'll describe offset and array functions in CAD, and we'll look at something called Boolean Operations to generate and create 3D geometry. It's not as difficult as it sounds. Using drawing layers are available in most CAD software, and their main benefit is to help separate the data on the screen or in a CAD drawing. So let's say you've got a complex drawing with lots of elements of the part, or if it's a layout as in the picture we've got, lots of different layouts all on top of each other. You can utilize layers to split that data apart to make it more easy to read. Now, the layers can often have different colors, so you can have certain elements in certain colors. You may have dimensions in one color, you may have parts in another color. If it's on a drawing, it could be the drawing template could be different. Now you've all got a bit of experience of this in Solidworks, and on the next slide in this presentation you'll see where I go through the building of a part in Solidworks and I add it to a drawing. In this short video, I'm going to show you about layers on a drawing. So we're in SolidWorks here, and all I've got you to view is the drawing page itself. You will already be familiar with, or you should already be familiar with, the fact that we have two layers. This title block and outer border that we have behind our drawing is greyed out and is not editable, and I can't do anything with it. However, all the information that sits on top is on its own layer, and I can move this about and change things and add bits and pieces to it. So let's just have a look at the benefits of this and why we have different layers. So the first thing I'm going to do is to jump into the edit sheet format. There we go. So now I'm on the very bottom layer, and this is the layer that defines this title block and this outer border. If I drag and move some of these around, you can see now that I can do things to this that I couldn't do previously. Let me just take that one back up a little bit, and once I finish with this, I'm going to exit this layer, and then I'm going to go and work back up on the main layer. So there's a little button just out of view, and there we go. The outer border is now gone grey and I can't edit it. So that's one layer, that's the title block layer. The second layer that we have then contains all of this information. Now we can add additional layers in SolidWorks. If you go up to the insert menu, you can go to layers, and I've just pulled out the tool here, and I'm going to click on this little button here which is for layer properties, and you'll see that I've set up a couple of different layers. So the first layer is the format layer. That's defined by a black color. The next layer is annotations, which is purple, which is why this annotation here appears purple. And then there's a dimension layer which is blue, and again that's up here. So these other buttons that I've got here, I can turn the visibility on or off, and if I flick on that, there we go, we can see that layer is being shown or not. The format layer, I've actually not got anything on that at the moment, and then the dimension layer, I can turn that on and off as well. Now the next button to it is the print button. So I can print this drawing but omit the annotations or omit the dimensions. So it gives us a lot more control over how we view and how we can print our documents. Why would we want that control? Well, it's just to make things easier really, and to make things clear. So let's suppose this was quite a complex drawing, and there were lots and lots of dimensions and things were a little bit chaotic. I could quite easily close off specific dimensions that I've attached to a specific layer. I could show just regions of the drawing. So for a complex drawing, it makes things easier to view. If I click on this color, I can change and edit the color quite easily. So I'm just going to pick another one, click OK, and then you can see these dimensions have turned green. So there we go, that's layers. You can add as many as you want in Solidworks and in most software, and then you just assign different elements to different layers. You can change the colors, you can change their behavior, and that makes it easier to view and print the things that are important at that particular time without losing any more information. Now we're going to look at some of the benefits of using 3D CAD, and we're going to take this into a bit more detail than what we've done in the other videos. So one of the big benefits of using three-dimensional CAD is the ability to move, rotate and zoom in and out of a model. Now again, I've created a short little video here of this in process. The benefits of three-dimensional CAD over 2D CAD or 2D traditional drawing. First of all, it's very easy in 3D CAD to understand what the shape of something is and how it should be looked at. This is because you can rotate and move this 3D model into any angle and look at it from any position. If this was a two-dimensional drawing, you would only have the views available that the designer has given you. This means that you may have to imagine what the shape looks like. Now, to a non-technical or a non-engineer, that might be difficult to envisage what something really looks like. However, you don't have that problem with three-dimensional CAD because it looks like a real three-dimensional image on the screen. Another benefit that we have is zoom. I'm going to zoom in until I hit the bottom of this part, and there we go. The zoom is so low here that this would be impossible to measure with most measurement devices or any specialist measurement device, especially in light of things like thermal expansion. I'm going to zoom out, and there we go, and I can also zoom out as far as I want. So one of the big benefits of three-dimensional CAD is the ability to view the model from any angle and from any zoom. So in this next video, we take it a little bit further, and we've got more of a complex shape. I'm going to show you some of the visualization tools and show you how 3D CAD can make working with these types of shapes much easier to do. Another benefit of CAD is that you can easily view more complex shapes, and you can have a look at all the different bits of detail. So in this video I'm going to show you some of the visualization techniques, and we're going to have a little look at this little water inlet tubing, and we're going to just inspect some of the elements. So first of all, I can change how the shape is displayed. So I can go into a wireframe mode, and that will enable me to see through all the different elements within this part. So I can see all the internals and externals at the same time. I can make that a slightly more simplistic line drawing, whereby now I'm only seeing the outer lines of the part, but I can still just about see through, and that can sometimes help me define exactly where I want to look with certain things. We have full wireframe mode. Now you can see this isn't displaying as full wireframe mode because this is actually an imported part, and the way that this part has been imported is in these tiny little triangles all over the part. So we're currently looking at the outline, but we're also looking at these little triangles as well. I'll explain those in another video. We can go to a outer part with no edges, so it's not showing a defined edge to anything, and this is often a more realistic view for a part. or we can have the edges on as well. So a couple of the tools. Another tool that we have here which is really beneficial is the sectional view. Now a sectional view, you should know, is an imaginary cut line through a part. And I'm going to use this cut plane, so we're currently looking at this front plane. If I pull this front plane up, we'll start cutting into the part, and we can then inspect any of those elements as the part is having this cut section applied to it. So that's a really big benefit of 3D CAD, and I can change that cut plane into different orientations. I can have a look at all these different edges. I can be checking the wall thicknesses on all of these to make sure the part's going to be strong enough, make sure there's no gaps. I can again switch it around into all these different views. I can actually do this on angular views as well, and I'm not, there we go. If I cut that down to angles, you can see I can cut up through this, but I can look at this part in any way I desire through a sectional view. Just going to turn the sectional view off. Another tool is in the Evaluate tab, and we're going to look at this zebra stripes and curvature. So zebra stripes allows you to see curvature very easily in a part. So there we go, this is zebra stripes on, and as I move it around you can see different elements that are in different planes will have curvature showing differently, and again whichever way I rotate this, so this enables me to see where there is bits of curvature in my part very easily. I'm going to turn zebra stripes off for the moment, and now I'm going to turn curvature on. So this is another similar tool, and this time it color codes it. So there's a little bit of color coding going on, not a huge amount on this one, and I can actually use these two together. So I can color code my zebra stripes just to make it look a little bit more clearer. So now one thing I am picking up with this is this bit of curvature inside here on this inlet pipe, which I couldn't really see in the other views. So if I turn those off, you can't really see how that curvature is working. But if I turn both of these on, there we go, I got the visualization on it now. I can see exactly what's going on with that bit of geometry. Nice and psychedelic, hey? So that's just a couple of ways that we can use the tools in SolidWorks to be able to view complex geometry in a little bit more of a clearer manner than just a standardized view or a two-dimensional view. The ability to rapidly change and adapt your designs is another huge benefit of 3D CAD. So in this little video, I'm going to show you how I change and adapt this model, and I'm going to start working towards a solution. And you can see the benefits of just quickly and easily adding and changing these different features and elements to my design. In this short video, I'm going to show you the benefits of rapid design change when using three-dimensional CAD. So here I have a wheel, and it has these spoked rims. So let's quickly change the circular pattern. So currently we have 8 equal spaced. Let's make that 16. So we're going to double the amount of spokes, and you can see it's just leaving me a little gap, so I'm going to accept that. And there's our spoke. One of the things that I'm going to do through this is show you how the changes affect the mass of the part. So here, the mass of the part, now I've made this change, is 70 kilograms. So this is a fairly substantial wheel. You can see that the diameter here is 890. So this is being driven by an equation. Don't really need to worry about that too much for now. Let's go back into this pattern, and just need to close something down. Right, let's go back into the pattern. Let's go and edit that pattern again, and this time we're going to go back down to our 8 spokes, and we'll just have a look at the effect that does on our mass. So go in, take the mass, There we go. We can now see that our mass is just under 100 kilograms. So that's a substantial weight increase. Okay, let's have a little change of some of this profile. So we can see that this main pattern has been made by a wheel. It's been made by a sketch and a revolve. So if I go in and edit the revolve here, and I'm going to do Control 8 to make it go flat on the screen. So I want to make this central hub a little bit bigger now. We want to bulk this up a little bit. So let's make it 200. So there we go. You can see that that's now substantially bigger. I'm going to come out. There we go. The central hub substantially bigger. Now the way that I've utilized these cutouts, it's also made those cutouts smaller. So let's go back into our design, and this time we'll go back in and add our 16 spokes back in, just to strengthen that right back, to reduce some of the weight in the wheel again. There we go, nice and quick and easy. I want to now add a couple of chamfers onto this wheel, because I don't like this little sharp edge in here. We just want to take that edge off a little bit, so I'm just going to do a 2mm chamfer with a partial preview, and let's see how that goes. There we go. So that's just adding a little bit more strength there now to that part, and I'm happy with that. So I'm going to add another one here, and we'll add another one. Just take a bit of weight off there, and we'll take a little bit off that one. Okay, let's go and see what the mass of our part is again. So mass properties, there we go. So we're still substantially bigger because we're 129 kilograms now. That's because we made this central part really big. Let's take a bit of the weight out of here. Okay, so we're going to aim to get this down to about 50 kilograms, which is pretty much where we started. So I'm just going to leave a bit of something there, and we'll do an extrude. Now we won't be able to do this all the way. In fact, what I'm going to do is cut a central hole out. Let's put a smart dimension on there, and we can see that's 350. Let's make it 80mm for a central hub to go through, and we will extrude cut, and we'll do through all both, which means it will cut it out through both of them as far as it needs to. Now I'm going to come in and do another one. I'm going to draw on this edge. I'm going to do an offset. Click on this edge. Let's change the dimension to 20, and on this edge, oops. Right, where am I going? Right, so that 120, let's reverse that one, hit the tick. That's what I didn't do on the first one. Select that edge, offset, 20, hit the tick. So now what I'm going to do is trim this little bit out here, but we'll still leave a little bit of material left. So I'm going to do extrude cut, and I'm going to cut it a depth of 60. There we go. So I've thinned that out. There's still quite a lot of material there. So I'm going to do the same on the other side. So I'm going to reuse that sketch that I just created. And yes, you. I don't need to edit you. So I just need to select it. Feature. Extrude cut from the surface that I select, and I want to extrude cut you line 60 that way, and there we go. So we've took out a bit of weight in the middle of there, and let's go and see what our weight is. So mass properties, okay, so now we're down to 96 kilograms. Now remember, I said I was going to try and get this down to about 50 kg, so I may have set myself an unrealistic target, but let's see what else we can do to this. So we've got a big chunk of material in here, and if I cross section this, there we go, we can see all of that material in there, which is loads. So I'm just going to make these cutouts a bit deeper actually. So let's go back up into here, into the feature. Let's change that to 80. Hit the tick, and let's change this one to 100. Let's see what that does. There we go. So I'm not sure if that's going to cut through. We'll have to see. Nope. So let's cross section it again. Let's see how much material we've got. Oh, not an awful lot now, which might be beneficial. So let's just switch that around into a different direction. There we go. So we can see that I've taken out the majority of that weight that's in there. And there's probably not much else I can do with that. So let's get rid of that cross section and go and take our weight again. Now we're down to 81. I think my 100 may have been a bit optimistic. Let's see what else we can do. I tell you, let's take a pattern out of here. So I'm going to draw a bunch of slightly offset holes to keep some stability with this. Ooh. There we go. Feature, extrude cut, through or both, hit the tick. There we go. So we're going to make this central bit into a bit of cheese. Let's do a circular pattern, and we're going to go around this edge, not that face. We're going to do equal spacing, and now the features, if I come down here and select the feature from here, there we go, and let's increase that count. Oh, don't know if we'll get away with that one. Let's go to 11, hit the tick. There we go. So that's some cooling for our brake disc. And let's take a weight. And now we're down to 79 kilos. And so forth. So what I'm trying to show you here is that you can rapidly change and adapt the design of something to suit what your intention of your design is. And that's a big benefit with CAD. And then we're also analyzing the data really quickly just to see how much more we can take out, how much further we can go. Now let's just do one other thing before we go too far. So Control 8. So I'm just coming in to have a look at this. Let's see if I can take a bit of sizing out of here. So that 30 there. Let's take him down to 15. That'll thin the wheel out a little bit more. And I'm going to lose this equation here. Just going to turn that equation off. And I'm going to just delete that size there. And let's now dimension that to let's do 90 that side. That side was 100, so our hole now is going to go all the way through, which is why we've got an error. And if I scroll around, you can see that we've got no material in here now. So I'm just going to go Control Z, take it back to where it was. Okay, and yeah, we'll leave it there, I think. So what you've seen is me just rapidly adapting and changing my design. Now, if I was doing this by any other method than 3D modeling, these changes just wouldn't happen that instantly. And we would then be adding more time and more cost to our design process. In our final benefit, I'm just going to quickly run through again how we can pass a SolidWorks model directly into a CAM system, and I'm going to use a 3D printing process again because that's what I've got quick and easy to hand here. This process would be a little bit different, but not massively. If you were using an industry standard machine, you would still take the model out of SolidWorks and put it into the CAM software, and you can use the two directly together. Now, one thing to note, there is the ability to program CAM in SolidWorks. I don't want to get into that in this session. However, you don't even have to leave the SolidWorks environment anymore. Another benefit of CAD is that we can pass CAD data straight into a CAM system. What I've done here is created a little vase that I'm going to 3D print, and I will show you how to take this out of SolidWorks, out of our CAD system, and put it into the CAM system for the 3D printer. So all I've done here is to create a revolve, and I'll just cross hatch it for you. There we go. So I created a revolve, created half a section, revolved it around the center line, and put a little flat on the bottom here, and that flat will enable me to put it on the 3D printer plane nice and easily. If it's a rounded bottom, then it won't have a lot to stick to the bed on the 3D printer, and potentially we could get some misprints come out. So I've just put that little flat bottom on. This is about 100mm high, and the first thing I'm going to do is to save this file. I'm going to do save as, and I'm going to save it as a part. That's my first one, so let me just pop it on my desktop. Let's call it vase. Ooh. So that's a SolidWorks file that I've saved, so I can come back and edit it later. I'm then going to save as, and this time I'm going to change that to an STL file, which is a stereolithographic file. And again, I'm going to pop that on my desktop next to the other one. Hit save. It converts it into a binary file. So I'm going to come out of SolidWorks and I'm going to open up Cura, which is the CAM software for a 3D printer, and you can select various 3D printers. So I'm using the Ultimaker 2. There's a couple of settings across the top, so I'm not going to worry too much about. I'm going to do File, and I'm going to open File. I'm going to go and find the STL file that I just created. There it is, vase. Hit open, and it places the vase on the printer. However, it's put it in the wrong orientation, so I am going to just change the orientation very quickly, and I want to grab this red circle and drag it around. There we go. Hopefully, oh no, I've gone too far. Just drag it back one. There we go. It's now sat nicely on the build plate, and I've got a lot of other settings all ready to go. So the next thing I'm going to do is hit the slice button. Now obviously this process would be a little bit more intense if you were to be putting this into a CAM software to run a mill or a lathe or some other form of CNC tool. I'm now going to go to this preview button, and what I can do now is I can drag this down and see all the different layers that it's going to print, and I can hit the play button and I can actually physically watch this CAM cycle and see exactly how it's going to make this vase for me. So we looked at this in a little bit of detail in another video, so I'm not going to go through massively. So it's going to create the bottom. It's doing the infill for the bottom layer, then the next layer, and then it'll just build it up and up and up until we've got to layer 360, when it will have the final bit of the part made. Now, just something interesting that I've just spotted. Can we see here? This is the top of my model. This is the top of the 3D print. Now, why do you think that has not gone all the way to the top? Any ideas? You've probably guessed it correctly, because this thins out so much on top, it's thinner than the thickness of the extruded nozzle, which is 0.3 millimeters thick. So if we go down one layer, we should see that actually there's a couple of layers there that are just 1, 2, 3 layers, 4 layers that are just one thickness thick. So it just gets too thin for it to add that extra bit of data on the top there. So my vase is going to come out slightly smaller than what I want. In this CAM process, what it also shows me is how long it's going to take to print on a standard setting that I've got set up in here, and it's going to take 99 grams of material, which is 12.48 meters, and if we're looking at 100 meters is roughly £15, then that's going to cost us about £1.50-ish, £1.80, somewhere around there in material to make that little vase. Okay, thank you. So now we're looking into some more of the techniques in CAD, and we're going to start by looking at array patterns and arrays. There are two different types that you can create. One is called a linear array, which is done by multiplying something on the X, Y or Z, or multiples of each axis. And then the second one we're going to look at is a circular array, and I'm sure most of you would have had some experience with a circular array. And we're going to cut a circular pattern using the hole tool and the patterning tool in Solidworks. We're now going to quickly look at patterning, and this is another word for creating an array. And an array is a duplication of parts, often in either a circular pattern or in a two-dimensional rectangular pattern. So here's our part at the front here. I'm going to use the linear pattern feature in Solidworks. I'm going to select my direction 1 as this horizontal. I'm going to duplicate it 3 times. Then direction 2 I'm going to select as this vertical here, and I'm going to flick that arrow to make it go up, so my parts are going to go up. Next I'm going to select the body that I want to pattern, and I'm going to select the whole part here, and you'll see once I hit the tick, it's created for me an array of parts, a 3x3 array of parts, which I can then utilize in my part or in my assembly. So using the pattern feature, then I can duplicate parts. I can also duplicate individual features if I wish. Let's say I'm going to create a gear system, a gear, and I want lots of teeth. I design one tooth, I cut it, I then use a pattern or an array to duplicate that around the rest of the part to create all the teeth in a circular manner. So what's the benefit of this? Let's imagine we're creating an assembly of a chain system or of a roller bed system, and we've got a bunch of rollers that we want equally spaced out across a specific length. If we were drawing this manually, we'd have to draw every single one of those rollers. However, in Solidworks we can duplicate those rollers over and over and over to create the exact array that we want, thus saving us lots of time. In this video I'm going to show you how to do a circular array. We're going to cut some holes, some circular holes into this little flange as little bolt holes so this can get attached to something. So the first thing I'm going to do is to create my first shape. So I'm going to draw a circle and I'm going to make it horizontal here. Give it, oh, that didn't quite work. Move too quickly. Smart dimension. I'm going to make my hole 14 mil, and I'm going to make sure that with a relationship it is horizontal to the center point. There we go, horizontal. And the other thing I want to do is to smart dimension the distance from the center of my circle, and I want that to be 85. So there's my first one, which is called the parent. What we're going to do first of all is cut it. I'm going to do an extruded cut, and then we'll do it through all. And there's our first feature. So what I'm going to do now is to create the array, and I'm going to pattern this circle equally spaced 8 times around this circle. So we're going to go to our circular pattern tool, which is underneath the linear pattern. I'm going to select direction. So this now I have to pick a circular point, and that will then use its center point as a reference to pattern. I'm then coming down here, so features, what features do I want it to pattern? I want it to pattern that cut, and you can see that at the moment it is patterned 15 degrees this way, and I have 2 of them. What I'm going to do is change that direction so it can go the other way. I just always like to work clockwise. I'm going to hit equal spacing, and now it is equally spaced them, so they're 180 degrees each side. If I now change my count up to 8, you can see that pattern adding itself. There we go. So I've got this diameter 14 hole, equally spaced, and with a count of 8. So it's going to put those 8 holes equally spaced from this one to the center point, and I hit tick, and there we go. So Control 8. There's my part now with its bolt holes all intact, and I've only had to draw one, and I've used the pattern or the array tool to create a circular array to stop me having to duplicate the building of each of those holes individually. The offset tool in Solidworks enables you to create new objects that are parallel or concentric to another object at a specific distance. Now you think this is quite similar to the array tool. However, with the offset tool, you're unlikely to create multiples. It's just going to be individuals. So in this video, I'm going to change the size of this shape using the offset tool, which enables me just to duplicate something at a certain distance. Another advantageous CAD tool is offset. So here we have a part that we've been using, which is 50 by 50 with a 20 by 20 cutout. I want to make this part 60 by 60 and maintain our cutout as 20 by 20. So rather than me now coming up and resketching all these parts in and then adding all the dimensions in to make it fit, Solidworks has a tool called offset. If I click on offset, I can now click on individual lines or edges, and it's now taking a pattern of all of the lines I've selected and creating an offset into this dotted yellow line, and it will create a new sketch. However, it's not quite what I wanted, because I wanted it to go the other side of the line, so I'm going to reverse the offset, and there we can see it's offset, and I'm going to hit the tick, and now I have this specified 10mm distant offset around the initial part. So I'm going to close those up, and I'm going to trim the bits that I don't want, and then I'm going to add in very quickly a couple of dimensions. And that one should do it. Now, when it adds offsets, it doesn't automatically add in the horizontal and verticals. So let's drag a corner and see what we're doing. So we can see that one's going out of horizontal. So I'm just going to make these go horizontal and vertical. Make you go back horizontal, please. Sorry, vertical. There we go. Now my sketch is fully defined again. Now when I exit, it's going to automatically crash. I'm going to continue, and I'm going to close that, and there we go. And it's re-added my pattern, so let's get rid of the pattern briefly, and there we have it. There's our new part that's now 60 by 60. And now we come on to the fabled Boolean operations. So what is a Boolean operation? Well, it's a bit of logic, and it's something that's used in algebra, and it's for creating something which is a true or false statement. So this is a bit of a strange piece of terminology. This is a strange bit of terminology for using in a CAD software. However, it is very, very important. So in the video on the next page, and I've done it full screen so you can see exactly what's going on, I'm going to create these 3 separate pieces of part data, and it all derives from 1 square and 1 circle. So one of the operations, the union, we're going to add things or join things together. The intersect, we're going to take an area that's overlapping, and we're just going to use that bit of shape. And then subtract, we're going to use the overlap to subtract other elements away. So for me, Boolean is a bit of a strange word to be using in CAD. It is correct, it is the right word. It's just not something that a CAD designer or somebody who was using this software on a daily basis would probably use. But it's things that you would do, but it's not things that the terminology isn't there that you would use all the time. Now, please be aware of this, because there will probably be a question in your exam on Boolean operations, so it's useful to know what the 3 different types are. In this video, I'm just going to quickly show you some Boolean operations, and that's where we can utilize different shapes to create different things. So I've created an array of this little rectangular square, it's not quite a square, and this circle, which are creating different regions within each of these. So what I'm going to do is show you something called union, something called intersect, and something called subtract on these 3 sketches. So it's an identical sketch, I'm just going to extrude them in slightly different ways. So if I go to feature and go to extrude, because I've got multiple areas and it's not one enclosed profile, I can now use selected contours to pick what I want Solidworks to extrude. So in the first one, I'm going to select all 3 areas, and Solidworks will join all of those together to create a union of those shapes. So union will join things together. I'm now going to do a second extrusion, and this time I'm going to extrude just this middle bit here. So I'm just extruding the intersection between the 2 shapes that I've drawn. I'm going to hit the tick, and there we go. So now we have just the intersect, just the area within here where the 2 elements meet each other. And then finally I'm going to do an extrusion, and this time I'm going to do something called subtract. So I'm going to take the rectangle at the bottom and I'm going to subtract out the circle at the top. And there we have 3 different shapes. In fact, I could create a 4th. Let's create a 4th just to finish this off. I will create a subtract of that top shape there, and I'm just going to deselect that merge button. So here we go, our 3 Boolean operations. Let me just quickly label these up. So first one is called union, and that's where we've joined the parts together. Second one is called intersect, where we've utilized just the intersected area. And then the third and fourth one is called subtract, where we've subtracted away the intersecting area. And you can quite easily see, if I brought the intersect of this in here, I could create the union. So the subtract is just getting rid of the area of overlap. Now that may seem fairly simplistic, and it can be. Just imagine having an extremely complex shape and you wanted to duplicate that complex shape onto another part. A massive benefit of CAD is that you can do that as easily as what I've just done here. So you don't have to just work with sketches, you can do this with actual parts that are made in Solidworks, and I can intersect or subtract or join them together to create a more complex shape, to create a cutout, or to create the result of an intersection between two different parts. So these are called Boolean operations. Okay, so now we're on our final information page of this video, and I just want to quickly discuss the benefits of keeping backup files and regular saving of your data. So any of you that have been in the class with me, I'm sure you've seen either yourself or your colleagues or even mine, the software runs perfectly, and then every now and then we'll get a little glitch in the matrix, and you may cause a crash. There could be a power failure, or something could just get corrupt, or you could end up doing something you don't really want to do to your model, and you could end up losing it. So it's very important for you to auto save your files as you're going. Once you have your files, people only usually create one copy of their file, and the problem with that is, what if you have a crash? This is my data file that I've saved all of your work on and all of my teaching materials, and it was working perfectly well until about a month ago, and it's decided it no longer wants to read. So the data is on here, but I can't access it. So that is my backup. It's not my backup, that is everything. That's my one copy of a lot of files, so I don't really have a backup. So the stuff that's on there, useless. All that work gone. Okay, so luckily every 6 months or so I create another backup file, and I will back up all of that information. So all I've lost off that is about 6 months work, which is a lot. However, I haven't lost everything. So make sure you back up your files regularly. Make sure you create copies of your files as you're going. A negative of that is that you could end up with lots of files and you may not really know which one you're working from or which is your main data file. Another thing that I advise many of you to do when we're working with SolidWorks is, when you come to create drawings, is to actually save your drawings as PDFs, and that will be a date stamp, and that's kind of like a backup and a secondary copy for you as well. The benefit of using a PDF to save a drawing file is that you don't need SolidWorks, you don't need the original models, you don't really need the original drawings, so you've got a date stamp. The negative of that PDF is that you can't edit it later if you should want to. Okay, so just remember, always back up and save your work. Okay, so just to summarize what you'll need to look at, the information you'll need from this video, you'll need to describe 5 benefits of using 3D CAD. We've covered a number of them in this session. Look at the ones near the beginning. Explain 3 purposes of using layers in drawings. So why do we need layers in a drawing? Why do we regularly back up our files and data? And how would you do that? So write down the process. What are the differences between offset and array? And don't just write the differences down, write what each of them can do. Okay, because you'll probably need to explain those at some point. And then finally, describe how the 3 different Boolean operations are performed and what differences they give the user. Okay, I want you to really get this word Boolean into your head, because you'll probably need it once and you'll probably never use it again, but it'll be worth a few grades for you. Okay, good luck.